We have three engines. The nose faces the rear. And next thing we're going to do is resheet the running boards. The Studebaker Speedo, which used to go up in here, obviously will not work anymore. The engines are covered so that they do not get molested by spray paint and other things. Now the fact is that there have been twin engine pickups in the past. Somebody has done this. But I wanted to make them over 1,000 cubic inches. Two engines totaling 1,000 cubic inches. So I could call it the Kilo Cube. K-I-L-O-K-U 3 overline B. And I was going to do it with big block Chevy or Mercruiser GM Marine engines or something like that. What ended up happening was I bought many engines for this. I bought this truck for $1,100 delivered. It had a Buick V6, a Chevy 350 Transvol's rear end, a Mustang brake pedal hanging in it, not hooked up, a hot rod that never got worked on after 1979. And so, short story is I bought a Buick Grand National super turbocharged motor. Then I bought a complete Mustang down the street, $600, a complete 86 GT or 88 GT convertible, beautiful. I was just going to put everything Mustang in this truck. And then I had another change of mind and I bought an 800 horsepower big block 454 engine from my buddy Randy. I said, okay, I really like to do the twin engine thing. He says, well, you got to duplicate the motor you just bought then. You can't have two dissimilar motors. I said, oh, man. Oh shit. So I'd already bought 3 motors. Okay, so I buy, I get on eBay and I find 2 502 Cruiser motors in Missouri for $8,300. I buy them, the guy screws me, I never get the motors. That's now 5 motors. I still wanted to do the big block deal, so big block Chevy motors. So I talked to a buddy of mine at Vortec, Bob Enders, and he said a friend of his just had 50 delivered to him from GM. This kid had bought 50 motors, like $4 a piece. And he says, Bob has a funny voice. He talks kind of like this. It's this kind of funny thing. And he says, hey man, these are great motors, man. They're like 375 pounds. They're only less than a Porsche, 6, and on and on and on. He goes, pound per horsepower, And I said, that's all great, but these are 350 cubic inch motors, 5.7 liters. I want 1,000 cubic inches. I need 3 of them to get over 1,000 cubic inches. That's the theme of the car. And then I thought, what the F? You want to be different. You want to do something exciting. Nobody's done 3 engines in a street car ever. I mean, tractor pullers, yeah, but not like this. The frame needs more beefing. It's a kind of a nice design with these round cross members and such, but it needs way more beefing. Because once these motors hook up on those tires, it's going to twist this thing like a pretzel. So we have to...
power brake Bob's opinion.
Yeah. And so, to that end, we've rigid mounted the motors. We're going to put additional struts per power brake Bob's recommendations, and already pre-designed by me to begin with, up here, so the engines don't try to twist the frame so much. We're going to run, after we run exhaust through here, we're going to run, hopefully, some stands out there on these motors. We're trying to get weight forward because all the engines here, there's 3 engines. These are GTO 2002 LS1 motors, brand new, 400 horsepower stock form. Computer controlled, electronically, managed, fuel injection, real easy. All 3 will be tied together right at this junction. What you see here is the back of a crankshaft, an adapter, an aluminum adapter, a CV joint, it's like a U-joint with ball bearings, and then the inverse over here to a damper on this next motor. This has all been special made. And this gets connected with a little short piece of 1.25 inch diameter, 28 spline axle shaft, about 9 inches long. Then it'll be covered by a decorative dust boot. Also keeps the oil from splattering. We have 3 engines. The nose faces the rear. The front end is the back of the car. That's where the transfer case comes in, turns the power, and puts it back to the rear end. To connect these motors, we're using adapter plate, CV, and an axle between. They'll be direct drive. One through the other, through the other. Time 30 degrees off, as explained before, to make it a true 24-cylinder engine. The exhaust right now is planned to be done by Gibson in Corona, and this may entail bringing all 3 engines together into one pipe here and coming back with a muffler in the space in here. There's also the possibility of running them under the motor, just one next to the other, and doing it with 6 mufflers. These motors are kind of interesting in that you can actually turn both the exhaust manifolds backwards, and you can turn the injection end for end. So as it turns out, we're going to run them in the standard normal injector at the front position. That works for us in this. And make a single 8-foot long valve cover that will unify these motors and give it more of that locomotive Allison diesel look.
Allison.
As it's a huge single motor. The balancer on the front of the LS1 motor doesn't have any bolt holes like this or any of that stuff, so it could not receive any kind of an adapter, this, to mate it to this area. So we went to ATI and had special balancers made with double keyways, so that not only is there one keyway, but there's another one here. And we had to take the crankshafts out of these 2 motors and have them double keywayed. And then there was some issues with that, and eventually we got ATI and the cranks to agree with each other, and so now we have these ATI balancers which are made to receive blower pulleys or other drives off the front, and we're using our adapters and our CV joints into that part of the system. On the back side of the motor, none of this was necessary. All we did is remove the flywheel, make an adapter, bolt our CV joint on, and we're good to go. The first 2 connect in exactly the same way. 1, 2, 3. The 3rd motor bolts in standard fashion to a transmission. A single starter mounted here, a 2 horsepower, what's called a high torque starter, made by High Torque, goes here. These are modified forklift starters that have enormous cranking power. And this one starter is a 2 horsepower unit, and it will turn all 3 motors simultaneously, we hope. The cooling for this is going to be provided by radiators, which will go along the edge of the bed at the top, between the bed and here. And I'll drop it down now and I'll show you how that's going to work. This is a temporary control. This will be mounted in the console. Everything attached to the engine can be no wider than this, and everything attached to this can obviously be no wider than this. So there's about a 10-inch space here, and about 100 inches, a little over 8 feet from here to the front. So I'm going to use radiators, approximately 10 by 30 inches, 3 of them, on each side. They'll all be connected through each other, and they will provide the cooling for 3 engines. There'll be a bank of fans below these. You won't see them because they'll be below the radiators, but the radiators are going to be about right here. And so you'll still be able to see past the radiators. You'll see the wiring, the headers and things like that, but there'll be this rather industrial looking grid here on each side. Each motor will have a different accessory. One will carry a pretty huge alternator, perhaps 220 amps. Air conditioning compressor, a power steering pump for the power steering, and an air compressor for the brakes and the lift system. And those will be spread across these motors, provided by Power Brake Bob, hopefully. The brakes, certainly. We're excited about the air brake system. It's going to provide stopping power for clearly a lot of go power. And with this kind of go power, you need big whoa power. The brakes themselves are, I think, 11.5-inch dual disc, a dual rotor, drilled, slotted, Willwood with Mark Williams calipers and Power Brake Service air system and lines. So we should have really, really good clamping power on this very fast truck. This is a beast.